And welcome to our webinar on best practices for working in large projects in GVERSE Geomodeling. So many of our projects contain many hundreds of thousands of wells, which is more than you would want to model in any geomodeling application. But by using the following suggestions and techniques, you can productively work in these large projects with good performance and results. Following this review, I will demonstrate a workflow for modeling in a project with over 250,000 wells and in an AOI with over 56,000 wells. So what are the recommendations? Use AOIs. Working in AOIs is always good practice because it maintains your extents should your global extents become corrupted. It better focuses your area on the reservoir you are interpreting, and it increases performance by reducing the number of wells to be modeled. Subset the stratigraphic column. This reduces the number of formations and surfaces that the model has to keep up to date, thereby improving performance. Set formations in stratigraphic order. This is necessary for a geomodeling engine to properly model the subcrop truncations. Set formation unconformity types. The geomodeling engine needs to know what the surface types are, either as a formation or an unconformity surface, in order to properly truncate the surfaces. Use load on demand. This feature allows you to load only the wells from cross-sections, a set of well-based filters, or a selected set of wells on the map into the geomodel, thus greatly improving performance. Use Quick Pick mode. Quick Pick mode allows you to pick tops and formations on a cross-section without invoking the overhead of the geomodel until you are ready to commit the picks to the database, thus delaying the updating of the model until you have finished your cross-section interpretation. Use modeling regions. Only the wells within the extents of the modeling regions are modeled, thus improving performance. This is like having a dynamic AOI within your AOI. You can switch modeling regions at will without having to close any overlapping cross-sections like you have to do when switching AOIs. Pick cross-sections on a filtered well-based layer. By defining your cross-section on a filtered well-based layer, you can eliminate wells that you do not want in your cross-section, like wells that are too shallow to penetrate the formations of interest or do not have the desired curves. Minimize the number of open cross-sections. The geomodeling engine is always working to keep all open cross-sections up to date as the interpretation proceeds. This puts greater overhead on the engine and can adversely affect performance. Close all unnecessary cross-sections after you interpret them to maximize performance. Use grid decimation on large isomap layers used for surface sources. Isomap layers can be used as surface sources in geomodeling. However, if the isomap layers are very large and have millions of grid nodes, they can slow the loading and modeling of these layers in the geomodel. New for 2019.3 is the ability to decimate the isomap grid nodes up to a 10 by 10 rows and columns, thus greatly increasing the speed of their loading and modeling. Keep the presentation template as simple as possible. Complex presentation templates take time to generate in a large cross-section. Keep the presentation template as simple as necessary for interpreting your cross-section, and your cross-section will generate and display faster. Apply the minimum number of geomodeling features necessary. The geomodeling engine will keep all surfaces and surface relationships up to date for as many geomodeling tools as are turned on. This takes time. If possible, keep all or most of the geomodeling tools turned off while picking tops. Once all the tops are picked, then turn on the required geomodeling tools and invoke the geomodeling overhead just once. This workflow is a demonstration of the efficiency of doing regional prospecting in GVERSE Geomodeling. The play is to look for the subcrop or stratigraphic trap in the Devonian Hunton Dolomite, a major reservoir in the Anadarko Basin. The Hunton is overlain by the Woodford Shale, one of the richest source rocks in the mid-continent, which makes an ideal reservoir, source, and seal combination. The Oklahoma Anadarko Shelf project has over 250,000 wells. The Northern Shelf AOI contains over 58,000 wells, more than one would want to put in any geomodeling application all at once. The subcrop stratigraphy that is to be modeled consists of the Arbuckle Dolomite, Simpson Clastics, the Viola Limestone, Sylvan Shale, Hunton Dolomite, and Woodford Shale. The pre-Woodford unconformity surface has been mapped and rests on top of the Hunton, Sylvan, Viola, Simpson, or Arbuckle formations as you come out of the basin. The trap is along the truncation edge of the underlying Sylvan Shale as it pinches out against the pre-Woodford unconformity surface. Before I start the workflow, I have to have a disclaimer. The interpretation of this hunt and play is solely the work of LMKR and is meant only as an example of best practices of prospecting in large regional areas using GVERSE geomodeling and not as an example of an ongoing play. Any similarities to other interpretations is purely coincidental. To interpret the Hunton subcrop in the northern shelf of the Anadarko Basin, I will demonstrate the following workflow. Examine the basis of the play in GeoAtlas and X-section. Many plays start from reconnaissance work done in GeoAtlas and X-section. Therefore, we are going to start the demonstration by looking at a couple of regional X-section cross-sections that help define the play. Set up the model in geomodeling. Next, we are going to shift over to geomodeling and look at the initial setup of the geomodeling engine, including the model surfaces, surface types, conformance relationships, unconformity networking, and zone isochord definitions. Open the GeoAtlas map in geomodeling. In geomodeling for 2019.3, you can now open the same map as you have in GeoAtlas. This feature allows you to have the same layers in the geomodeling open as you have in GeoAtlas. Open X-section cross-section in geomodeling. Also new for 2019.3 is the ability to open X-section cross-sections within geomodeling from either an X-section layer or by browsing to the location of the X-section cross-section files and selecting one or more cross-section files to open in geomodeling. Examine the Hunton subcrop pinch-out in geomodeling. The Hunton pinch-out beneath the pre-Woodford unconformity will be examined in the migrated X-section cross-sections in geomodeling. Create grid of cross-sections in geomodeling. Two methods for opening cross-sections in geomodeling utilizing the load-on-demand features will be demonstrated. One method that is new for 2019.3 is to use the Area Selection tool to select a strip of wells on the map, then automatically sort them in either a north-south or east-west orientation to open them in cross-section. The other method is to select another strip of wells and load them into the interpretation, followed by defining a buffered projected cross-section along the strip of loaded wells. Apply the unconformity modeling in geomodeling. Once the grid of cross-sections are defined and interpreted in geomodeling, the modeling tools will be applied to generate the subcrop map and Hunton isochord map. Examine the prospect area. The pre-Woodford structure map will be displayed on top of the subcrop and Hunton isochord maps to define the subcrop stratigraphic trap. Refine the model. Next, all of the wells with Hunton picks are loaded into the geomodel in the area of the play. This will refine the extents of the prospect. Apply a modeling region to focus on the prospect area. Within the play area, a modeling region will be defined. Only the wells within the area of the modeling region are loaded into the geomodel. This further focuses the interpretation within the play area and greatly improves geomodeling performance. And now for the demonstration. This is a GeoAtlas map of the northern shelf of the Anadarko Basin. There are over 250,000 wells in this prospect, And as you can see in WellBase, there are over 58,000 wells in this area of interest. Now there's already been some recon work done in X section, so we're going to turn on the X section layer of these recon cross sections. Make it the active layer. Select the middle north-south cross section. And let's open this one up in X section. Let's maximize X section. Scroll down here and zoom in to the right side of it. You'll see the pre-Woodford unconformity here. Here's the Hunton, the Sylvan Shale, the Viola, and then down into the Simpson. This is a producing well in the Hunton. Let's look at this well in WellBase. And on the production tab, notice it's producing over 217,000 barrels so far. We'll open up the decline curve and notice the shallow decline indicating a probable good water drive and an ultimate recovery of over 916,000 barrels. So this is a pretty good well. Now let's select the pre-Woodford unconformity. Let's flatten on it. And as you go into the basin, notice that the Hunton thickens into the basin. So it looks like we have a good stratigraphic trap indicated by this good X-section cross-section. So let's close the cross-section for now. We don't need it anymore. And we'll move over to GVERSE Geomodeling. In GVERSE Geomodeling, we're first going to look at the Geosurface model properties. This is how you interface with the topology engine. The list of surfaces here is coming from the currently active stratigraphic column. Notice they're placed in stratigraphic order. This is important. Also important are the surface types. They're either an unconformity or a formation. It's important to have the correct surface types in order to do the correct modeling for the subcrops. Notice also the source. In this case, the Woodford is being sourced from the data points coming in from WellBase. I can also source the Woodford from an isomap layer. And new for 2019.3, I can decimate the rows and columns to make the performance a little faster. So we'll take every fifth row and column for the Woodford unconformity. For the pre-Woodford and the rest of these surfaces, we'll just take the data points coming out of WellBase. For surface constraints, I've got the pre-Woodford unconformity controlling the conformance of the Hunton, Sylvan, Viola, Simpson, and Arbuckle. I'm also networking the unconformities with the younger unconformities, cross-cutting the older unconformities in sequence. In addition, I have a zone map, which in this case is an isochore map between the top of the Sylvan and the base of the pre-Woodford unconformity, which defines the Hunton isochore map. Go ahead and close that. When you first open up geomodeling, it opens to the full extent, so you're seeing all of the townships that cover the 250,000 plus wells in this project. So the first thing we'll do is just zoom to the area of interest. And then from the Home tab, we're going to open up the GeoAtlas map that we had open in GeoAtlas. We just browse to that map, and it will open up the very same layers that were there in GeoAtlas. Now I'm going to turn on the Woodford, which is sourced by the isomap layer. You'll see it displays pretty quickly, even though there's over 3 million grid nodes there. But remember, I decimated it on a 5 by 5 rows and columns. There it is, pretty fast. We'll go ahead and turn that off for now. We don't need it at this point. But we're going to turn on the recon layer. That's that same layer that we had from X section layer that we showed in GeoAtlas. And I'm going to turn on the selectability of the recon layer. And then select that same middle cross section, that north-south middle cross section. Right click, and we're going to add that X section from X section, convert it to the format of the geomodeling cross section, and add it to the interpretation. So it actually converts it very fast. Now, do I want to go ahead and open it? I'll say yes. Let's take a look at it. So that's the very same cross section that we were seeing over in X section. So let's go ahead and zoom in to the same area where we saw the hunting before. So there it is. There's the hunting. The same good producer that we showed in the production table in Wellbase. So let's go ahead and close that for now. That's now been added to the list of cross sections over here. So I'll go ahead and turn off that for right now. Now, another way you could add the X section cross sections is from the Home tab, Open X section cross sections, and this one happens to be in the global AOI. So just browse to it, and we'll open that one up. Again, it takes very little time to actually convert it, but we'll go ahead and display that one. So there it is, with a full screen and full extents. Activate the hunting, and we'll go ahead and flatten on it. And zoom into the hunting. So again, there's the thin hunting right there, and as we move back into the basin, again, notice the hunting thicken as you move into the basin. Go ahead and close that one. It's already saved, and it too is added to the list of cross sections in geomodeling. Turn that off, and we'll turn off the recon layer. The next thing I'm going to do is turn on the hunting type cross section through a currently producing field. Make that the selectable layer. Select it, right click, and we're going to zoom to the selection. Next, we'll go ahead and open that cross section. And again, we're going to look at the hunting in this producing field. And to the north, out of the basin, you see that you pick up some of the hunting, but right through here is producing. So we're right at the edge of the hunting where there should be some variation in the unconformity that's cutting in and out of the hunting. So that's setting up the play for us. Go ahead and close that for now. And we're going to zoom out. about to there. And we're going to make the selectable layer a well-based layer that was generated with a filter for wells greater than 5,000 feet with gamma ray curves. So with that as the active layer, we're going to select a narrow swath of wells right through here. Right click and create a cross section. Now this is new for 2019.3, where I can select a cross section in a north-south orientation. And so we're just going to ignore the wells that are too shallow and just look at these wells. And again, you can see as we come out of the basin, we lose the hunting. So there's a truncation trap right through here. So I'm going to close this. It's going to ask us to save. I've actually already saved it, so don't need to save it again. Clear that selection. So that's one way in 2019.3 that you can open up the wells by simply selecting them. And then those wells will be added to a cross section in either a north-south or east-west direction. Another way you could create a cross section with the load on demand feature on, and this you can do in actually 2019.2 and earlier versions, is I'm just going to select a swath of wells right through here, something like that. Right click and load those wells into the interpretation. This loads those wells into the GeoModel, and then from the cross section tab I'm going to select Define Buffered Projected Cross Section and select a line of section right through here. Right click in the definition. Now I am going to have to select a predefined template, so here's my hunted correlation template. And again, ignoring the too shallow wells. Zoom in right through here. And then there again is the hunting right through there. Now as I move over to the east, I actually lose the hunting over here. So we've got from the surfaces, if I select that surface, that's the pre-Woodford unconformity. There's the viola. And so we've actually lost the hunting until we get into this area. And you can see as I move through this area and select those wells, there's the wells in the field. And then over here I've lost the hunting. So I can go ahead and close this, and I've actually already added it to my grid of cross sections, so I don't have to save it again. And let's zoom out to full extents. Now in my interpretation workflow, I've gone ahead and done a grid of cross sections that I'm going to open up here called my regional cross sections. And what I've done is used either technique that I've just showed you to create a grid of cross sections. And as I use these techniques, these wells are automatically loaded into the interpretation. Now I'm going to go back to the Home tab and open up the Geosurface Model Properties dialog box just to remind you how we've got the Geosurface model set up. I'm going to turn off the Woodford because I don't need that in the interpretation, because I've got the pre-Woodford down through the Hunton, Sylvan, Viola, Simpson, and Arbuckle set up. My surface constraints are from the pre-Woodford controlling the conformance of the Hunton, Sylvan, Viola, Simpson, and Arbuckle. I've networked the series of unconformities with the younger unconformities cutting the older unconformities. And then I'll remind you of my Hunton isochore map. Next, we will apply the geomodeling tools. The conformance tool, the unconformity trimming tool, and the unconformity networks tool, and then update the model. Now once the model has updated, we can look at the subcrop in the Arbuckle, which covers the whole region, the Simpson, coming up to the Viola, Sylvan, which shows the truncation edge of the Sylvan against the pre-Woodford unconformity. Now if you turn on the pre-Woodford unconformity structure map, you'll see here that the edge of the Hunton is forming areas which could be very good stratigraphic traps. So let's turn off the subcrop and turn on our Hunton isochore map. Now this is showing a color-coded thickness of the isochore map of the Hunton in the pre-Woodford unconformity. So this is the area that is very interesting and the area that we're going to be looking at to develop our play. Now for clarity, let's turn off the grid of regional cross sections and let's zoom into the area of our play. Here's area right through here. And I've got a cross section that is the Hunton embayment cross section. We'll just turn this on, and that's a cross section right through this area, right through here. We'll open that cross section. Let's zoom into the area of the Hunton down here. And for clarity, let's go ahead and we will flatten on the pre-Woodford unconformity. And again, you can see right in the middle of the embayment is that thick Hunton. Now this is that same well that had that really good production, EORs of close to 917,000 barrels. Let's go ahead and close that cross section. Don't have to save it. Now I'm going to select the well base layers with wells where I've gone ahead and picked the rest of the Hunton. So this is the area we're going to focus on. So with this well base layer of Hunton picks, click the selection tool, select this area right here, right click, and load those wells into the geomodel interpretation. Now when these go into the geomodel, it will update the geomodel and further refine our play area. I'm going to go ahead here and turn on the contours of the Hunton isochore so we can see the thickness of it. And that's 25, 20, 15, 10. So right through here, let's zoom in a little bit closer. is a potential area for development. This is a hunting field right here, so we have a potential area of development between here and this existing hunting field down here. Now, to further refine the play and also enhance the performance, I'm going to define a modeling region around our play. So first, let's zoom out to an area something like this and select our selection tool. Come down here and create a modeling region, and we're going to define the modeling region something like this, just around this area down to about, I would say something like that, gets the whole area. Give this a name. Let's call this our hunt and play. Now you could have more than one modeling region. So you can select these modeling regions and then activate it. In whatever modeling region you've defined and activated, only those wells within the modeling region will be modeled, thereby reducing the number of wells in the geomodel and thus increasing performance and also focus of the model in the area of interest. Now this becomes very interesting now. These are our wells that are producing from the hunting. This is also a hunting field down here. We can go ahead and select those wells within the hunting area of our play. Right click and let's create a cross section in a north-south direction. And let's zoom in for clarity. And there you can see, as we move across the field, there's our good hunt producer, and to the north through here we pick it up also on the edge right through there. So there's our producing wells, and then over here to the north we've lost the hunting. So there's our truncation play. Let's go ahead and close this. We don't have to save it because we can easily create it later. And so now we've used the geomodeling tools to define the limit of production based on the truncation edge of the hunting, and we've outlined a good area now to focus our land acquisition, to acquire land to develop our play. The purpose of this presentation is to demonstrate best practice when working with GVERSE Geomodeling in large regional projects and AOIs with many thousands of wells and dozens of tops. Depending on the style of the play, interpreting in geomodeling can be many times faster, more accurate, and much easier than interpreting in GeoAtlas, X-Section, and ISOMAP because the interpreter is working in a dynamic 3D environment where all of the surfaces and the surface relationships are kept up to date as the interpretation develops. There is no need to stop, create isomap layers, perform grid operations, or manually create truncation edges or fault polygons, as the modeling engine does all of this for you on the fly. The prospect can start from either an existing GeoAtlas map and X and cross sections, or from within the geomodeling application itself. In geomodeling, start an interpretation with no wells loaded using load on demand. Display in the map view a well-based layer containing the wells most likely to define the play either by depth, formation offset, or other pertinent data. Make a grid of intersection cross-sections to define the limits of the play by either importing existing X-section cross-sections into the geomodel, or directly within geomodeling with buffered cross-sections, or by creating cross-sections from selected well-based wells from the map view. Pick the desired tops on all the cross-sections. Use quick picks if necessary to improve picking performance. Apply the relevant modeling tools and observe the effect. Graphically add more wells to the interpretation in the area where you want to more model the definition. Create and interpret more cross-sections until the play is fully defined. If desired, use modeling regions for better local performance and definition. Thank you for your attention.